the very process of radioactivity, it was discovered, you can say accidentally, was discovered by a French physicist, Henri Becquerel. What happened was, uh, like I said, it was accidentally discovered because that physicist, he was investigating the process or the phenomena of phosphorescence, which is the emission of light by certain materials when they are exposed to light or some other forms of electromagnetic radiation, infrared, ultraviolet. So if you have certain substances, let's say you have a sheet of, let's call phosphorus, and if you shine light upon that or any other electromagnetic radiation, then there would be emission of light on that sheet of phosphorus or on that sheet of material. But what happened was, Henri Becquerel, he observed that a uranium compound, it would affect the photographic plate even when it is not exposed to light or any other electromagnetic radiation. So he was having a uranium compound, to be exact, it was like potassium uranyl sulfate, but the main content in that compound was of uranium. So he found out that uranium compound would be affected. It could darken a photographic plate. So if you have a photographic plate over here, that compound would darken the photographic plate even if there is no light or no other form of electromagnetic radiation. So what he realized was that uranium compound was emitting a certain kind of radiation that he then called uranic rays. And that was the time, and that was the process that laid the foundation for some other research in that field. And we have some other physicists and chemists stepping up on that. For example, Marie Curie. She also made a significant contribution towards the understanding of radioactivity. So let us define the radioactivity as you'll be asked to define in your exam. So I'll be writing in the key terms, you can note it down as it is. Alright, so in the exam they ask you for 2 marks, state what is meant by the radioactivity or define radioactivity. So you write down the definition as it is, and in the very definition you realize that there are at least 2-3 terms that needs to be defined further. For example, we have a word here, spontaneous. So a spontaneous process is a certain process. What kind of process we'll explain in a moment. And then at the same time you have radioactivity, a random process as well. So a random process itself has the definition, which I'm going to write in a while. And disintegration means just to break down. It is just the opposite of integration. Integration means to add up, to combine, to join together, and disintegrate means the opposite of it. And then you have the next in unstable nucleus. Alright, so unstable nucleus is a nucleus that is going to emit the radioactive rays. And there are a lot of factors. There's not a single factor that would make an element or an isotope unstable. There are plenty of factors. For example, the nuclear forces, and we also have neutron to proton ratio, and the isotope composition, energy levels, excess energy. So we have plenty of factors that would make an isotope stable or unstable. Primarily, it is the nuclear forces and neutron to proton ratio. But at this stage, we say an unstable nucleus is the one that emits the radioactive rays. Why is it unstable? That's not part of the syllabus. And the emission of energetic particles, and for this one, for these particles, we'll be categorizing them in different ways, and it could not be particles, sometimes it can be rays as well. So those rays we'll be defining separately, those rays and those particles. So let's move on to the next one. The nuclei of some atoms are unstable. The nuclei of some atoms are unstable. The nucleus of an unstable atom will decay to become more stable by emitting radiation in the form of a particle or electromagnetic radiation. So this is the reason for the radioactivity. In simple words, the atoms, some of the nuclei, some of the isotopes, they are unstable and they want to become more stable, and that's why they have to emit the radioactive rays. And once they do so, they are converted into stable ones. Now, in the very definition of radioactivity, I've highlighted the term spontaneous as well as the term random. So let us first define the term spontaneous. So this is the first one, the definition of the spontaneous process. So a spontaneous process is a process that is not affected by the changes in the atmospheric conditions, for example, temperature, the pressure, and these kind of things, the humidity, you can say. So if the external factors do not affect the process, then that process can be considered as a spontaneous process. All right, so like I said, radioactivity is a spontaneous process because it occurs without any external influence or intervention. Okay, so it is a natural and inherent property of a certain atomic nuclei to undergo the process of nuclear decay. And this spontaneous process of radioactivity, it is due to some fundamental characteristics of the atomic nuclei and the nuclear forces that determine their behavior. So external factors do not affect the internal properties, the internal characteristics of the certain nuclei. They are the ones that are going to affect the process of radioactivity. So since there is no external influence, we call it a spontaneous process. Okay, then we have to define what a random process means. Okay, so these two, they ask you separately for 2 marks, spontaneous separately and random process separately. So random process means alright, so this is how we define the random process. A process in which you're not able to predict which nucleus is going to decay and when it is going to decay. So not only the radioactivity is a spontaneous process, but it is also a random process. And it is considered as a random process. There are several reasons behind it, and one of them is the exponential decay and quantum mechanics. In quantum mechanics, we study this thing that the subatomic particles, including the atomic nuclei, they are governed by the principle of quantum mechanics. So the radioactivity, it would be having a probability. Like in quantum mechanics, everything has a probability. There is a probability of an electron being at a specific position. We can't say the electron is going to be here. In quantum mechanics, we say, okay, what is the probability that the electron would be at this point at a certain instant of time? Or what is the probability of the electron spinning in a certain direction? So everything has probability in quantum mechanics. But for you guys, you just need to memorize the definition of the random process and should be able to explain why the radioactivity is a random process, because you're not able to predict which nucleus is going to decay and when it is going to decay. And and due to this thing, the graph of decay with respect to time for the radioactivity, it is going to be a non-smooth curve. So in the exam they ask you this question: what is the non-smooth curve of the radioactivity with respect to time represent? So it represents that it is a random process. So they can ask you either way. Sometimes they can ask you, how does it tell that it is a random process? Or sometimes they can ask you, how is the random process reflected in the graph? So for activity has been a non-smooth curve. So the graph would be something like this. So you start from whatever the amount of that nuclei is, the maximum amount, then it starts to decay. It decays exponentially, but the curve is not smooth. All right, so something like this. You don't join the line on the x-axis. The curve does not have the x-intercept. Otherwise, it would imply that the amount of the source or the remaining nuclei is reduced to 0, which is not possible. We study in half-life as well. But the curve is not smooth. That is the most important part. It is not a smooth curve. A smooth curve would have looked something like this. So this is not a smooth curve. Why? Because the radioactivity is a random process. And for the radioactivity, during the process, the radioactive radiations which are emitted are classified into alpha rays, beta, and gamma rays.